If you are interested in creating 3D geometry and working in a 3D environment, you need to understand how to control the user coordinate system. The user coordinate system, or UCS, allows the user to define the X, Y, and Z orientation of the construction plane. You use the construction plane to create your 3D geometry. User coordinate systems can be really useful in 2D drawings as well. The UCS can be used to align a 2D view with geometry in your drawings. I show an example of that in a different lesson. The World Coordinate System, or WCS, cannot be modified. By default, the UCS and the WCS are aligned. They remain aligned until the user decides to redefine the UCS. To demonstrate how the UCS and WCS work, I'm going to create a 3D model of a bathtub. The UCS is color-coded with the x-axis in red, the y-axis in green, and the z-axis in blue. It can be helpful to remember the color codes when you are working in 3D. I'm going to switch to the 3D Tools ribbon. If you don't see a 3D Tools ribbon available, it's probably because you don't have that ribbon tab enabled. To enable the 3D Tools ribbon, right-click on an empty space on the ribbon, select Show Tabs, and left-click on 3D Tools. Notice that there are several tabs available, and you can control which ribbon tabs are displayed using this method. Another option is to change to a different workspace. I can go down to the status bar and switch to the 3D modeling workspace. This provides me with a lot more tools I can use for my 3D model. I can use the view cube in the upper right corner of the window to switch to a 3D view. Notice that the view cube is labeled WCS. The UCS icon is oriented to display the X, Y, and Z orientations, and it is currently aligned with the WCS. I'll start by drawing a rectangle on the XY plane. I select the rectangle tool from the Draw panel on the ribbon. The first point will be at 0, 0, 0, or the origin. The next point will be at 36, 60, 0. This defines the outline of the bathtub as 36 units wide and 60 units long. I'm going to extrude the rectangle up 24 units. I select the Extrude tool from the Modeling panel. I select the rectangle. I right-click and select Enter. I then type 24 for the height and press Enter. If you look at the Coordinates panel on the ribbon, there are several tools to help you move and manipulate the UCS. I want to draw a shape on the top face. By default, I would be drawing on the XY plane of the World Coordinate System. In order to sketch on the top face, I need to move my UCS to the desired construction plane. On the Coordinates panel of the ribbon, there are several preset orientations for the UCS. If I select the different orientations, you can see the UCS rotate, but it remains on the original construction plane. I'm going to move the UCS to the top of the 3D solid. I select the Object tool to move the UCS to the top of the bathtub. I select the top face of the bathtub, and the UCS moves to that face. I want to rotate the UCS around the Z-axis. I select the tool to rotate about the Z-axis and then use my cursor to reorient my UCS. To name the current UCS, I select the small arrow in the lower right of the Coordinates panel. I select the Named UCS tab. I click on the unnamed UCS and type Top of Bathtub. Now my UCS has a name. I press OK to close the dialog. If I want to restore the previous UCS, I can select the Previous UCS tool on the Coordinates panel of the ribbon and return to the previous UCS. From the Coordinates panel, I can select my named UCS from the drop-down list, and the UCS is restored. If I go over to the view cube, it displays that I am currently in the top of bathtub UCS. To go back to the original UCS, I just left-click on WCS. Notice that the UCS icon shifts to the bottom of the bathtub. To restore the named UCS, I can left-click on the named UCS, and the UCS returns to the top of the bathtub. I select the rectangle tool from the recent input. For the start point, I select the From Object Snap to start the rectangle 6 units in the X direction and 6 units in the Y direction from the corner point. For the second point, I type 24,48. This moves the cursor 24 units in the X direction and 48 units in the Y direction. I want to add fillets to the corners of my rectangle. So I type F for fillet. I type R for radius and set the radius to 2 units. I then right-click and select Polyline. Then I select the rectangle to add the fillets. I select Extrude from the ribbon. I select the rectangle. I right-click and select Taper Angle. I type an angle of 2 degrees and press Enter. I move my cursor down to indicate the direction of the extrude and type 22 for the distance of the extrude. I can use the drop-down list on the View panel to select a preset orientation. I select the front view. I switch to a right view. You can see the way the 2 different extrudes overlap. Notice when I changed the view orientation, it does not affect the location of the UCS. I select the Home icon over the View cube to switch to the default 3D view. I could also use the drop-down list on the View panel on the ribbon to select a preferred isometric view. I want to subtract the inner extrude from the outer extrude to create the bathtub. I can select the Subtract tool from the ribbon. I select the outer extrude first and press Enter. Then I select the inner extrude to be subtracted and I press Enter. To see what the bathtub really looks like, I select the Shaded with Edges visual style from the View panel on the ribbon. Now I have a tool in the upper left of my display window where I can switch from one visual style to another. If I hold down my Shift key and my mouse wheel at the same time, I can orbit around my model. To return to the default 3D orientation, I select the Home icon next to the View cube. To return the UCS to its original location where it was lined with the WCS, I can select World in the drop-down list on the Coordinates panel of the ribbon. The UCS is now located at the bottom corner of the bathtub. The UCS is a movable Cartesian coordinate system that establishes the XY work plane, horizontal and vertical directions, axes of rotation, and other useful geometric references.